Welcome everybody. This is your first official lesson of second semester, and we're talking about scientific notation. Now, scientific notation you're going to see throughout the entire unit, this unit 6 here. So it's a really important topic to pick up, and it's something that is seen a lot in science class. So maybe some of it will be familiar. Let's find out. So just in general, scientific notation is a multiplication expression. Now, remember the difference in first semester between expressions and equations. Expressions do not have equal signs. So there's no equal sign here, and it's written in two parts. So when we generalize things, formulas in math, we use letters to do so. So the general way of writing scientific notation looks like this: A times, this is a multiplication symbol, 10 raised to this n power right here. So the multiplication symbol separates the two parts. So this first part right here, the A, that is going to be a number between 1 and 10. Okay, so when we kind of write a number in scientific notation, we won't write A, we'll put a number there. And it should be a number between 1 and 10. And then the second part, this 10 raised to the n power, this n right here, this is called an exponent. Now, this whole unit, unit 6, is about exponents. So that's kind of why we start off with scientific notation, because it introduces the idea of what an exponent is. Now, maybe this n, and again, we're going to replace it with a number when we actually write scientific notation. So maybe we replace it with a 3. So let me give you an example. I'm going to use a different color. Maybe this will look like 10 to the third. We need to know what that means because we need to know about exponents this unit. So if you raise something to a power, that means you take this base, that's what this number is called, the 10, it's a base, and you multiply it by itself however many times the exponent says to. So in this case, that'd be 3. So 10 to the third would just be 10 times 10 times 10. Be 10 3 times. Okay, so that's kind of a basic intro to an exponent. You've probably seen that before. Now, if I look at example 1 here, they give me 4 different options, and they ask me which one of the following numbers is written in scientific notation. And I want to point out, you guys, that these are just numbers. Scientific notation looks all fancy and weird, but it's just a number. It's a way to write really, really big numbers and really, really small numbers in manageable ways. Okay, so if I see anything like this, it's just a number. Now, I want to identify, because only one of these is actually written the way it's supposed to be in scientific notation. So let's see if we can figure that out. I'm going to do process of elimination. So if I look at A, this is not in scientific notation because of the first part. It's 52. And I told you that A, the first part, needs to be a number between 1 and 10. So it's not that one. That means it's also not C because 0.04 is not between 1 and 10. So down to B and D, if you look at D, this is an addition expression, not multiplication. So it's not D either, it's B. You got a number between 1 and 10, and it's multiplication, 10 to some power. Okay, so that's kind of like analyzing what scientific notation looks like, the two parts. Now we're going to practice like converting. So you've got scientific notation and a regular old number. We just call that standard notation. So this huge number right here, that's written in standard notation. When I actually write the number out, I can shorthand this huge number and I can write it in scientific notation, which is a lot quicker. So like scientists, instead of writing this out, they would write the scientific notation, especially the bigger and bigger or smaller and smaller the number gets. Now, I need to write it in this general form up here, so here's what I'm going to do. Now, the thought process is this a really big number or is this a really small number? You guys can all tell that this is a really big number. You need to think about where the decimal is currently located. And the decimal is always at the end of a number. And to be specific, it's at like the right end here if they don't write it in. decimal's right there, even though they didn't write it. Think about where the decimal should be. And what helps you do that is this first part right here. I need to make a number between 1 and 10. So for me to do that with this huge number right here, I need the decimal to be over here between the 5 and the 7. So that way I have the number 5.7. So that's kind of my goal for the first part. I need it to be 5.7, so I'm between 1 and 10. Now you need to think about, well, how many places does the decimal need to move to get it there? Okay, so let's count that. The decimal is currently right here. I need it to be right here. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Okay, so count it in between each digit. The decimal needs to move 9 places. This represents your exponent. Or like it's going to be 10 to the 9th in this case. Now, one last thing to note, and technically I'm done. Another way to write this huge number is just to say 5.7 times 10 to the 9th. Okay, you need to think about one last thing. So again, this was a really big number. We could all see that. Whether it's a really big number or a really small number, that will change the sign on your exponent. So if it's a really big number, you want your exponent to be positive. So that's why I went with positive 9. But if it's a really, really small number, like example B here, I need to represent that by using a negative exponent. Okay, so here's what I'm going to do on part B here. So this is a really, really small number. You'll see it a lot again in science. Like they'll talk about like the mass of the sun or something, or the weight of like an atom. Really big numbers, really small numbers. Instead of writing them out, they'll do scientific notation. So this really, really small number here, to convert that to scientific notation, it's a really small number. Like I said, I have to think about where the decimal should go. Obviously, it's right here. I want to put it in between 3 and 1 to make 3.1. So count how many places it needs to move. 1, 2, 3, 4, 5, 6, 7. That represents what your exponent is. And since this is a really small number, it needs to be negative 7. Okay, so this is the shorthand version of writing this small decimal. Okay, moving right along. So example 3, this is the same idea, guys, but it's just going in reverse. So this time they're going to give me a scientific notation way of writing the number, and I want to write the number in standard form, or just like a regular number, a number that kind of makes sense to us. Scientific notation doesn't always make sense to us. Regular numbers do. So standard form is my goal. So here's what I'm going to do. I'm going to start by taking the 5.21 and recognize that the exponent is a positive 4. We can see that. So that tells me that this is a really big number. Again, if it's positive, it's a really big number. Negative, it's small. So that's going to help me decide which way to move the decimal. But here's what I do. I take the decimal, the number between 1 and 10, and I just write it down. I know that I need to move the decimal 4 places, and this is a really big number, so really big numbers, the decimal needs to move 4 places to the right. Okay, so to do that, I'm going to go 1, 2, 3, 4. That's where the decimal should go. Then you just fill in zeros. Because essentially all I'm doing is multiplying 5.21 by 10 4 different times. So it's just going to move the decimal over 4. Let's see, if I wrote that a little bit nicer without the little loop-de-loops there, it would be 52,100. Okay, so that's not that bad. I want to point out before we kind of move on and you try one yourself, if the exponent would have been a negative number, then you would just switch that all around because it obviously would be a really small number, and that would mean I need to move the decimal to the left. Okay, I do this a lot on the notes if you're kind of new to me here. Sometimes it'll actually say, like, you try this one. Sometimes I'll just circle it, and hopefully you're paying attention and listening and you catch that. But I want you guys to try this one on your own. When I check the notes next time I see you, I will check your answer, tell you if you're right or wrong. It doesn't mean you won't get credit if you get it wrong. I just want to see if you can do this. So I want you to write this scientific notation number in standard form, or just as like a regular old decimal number. All right, I'm going to move on to the back though and try a couple more. So this is example 4. Now, here's what I'm trying to do. I'm trying to do 3 times this really small, I see the negative exponent, whoa, really small scientific notation number. Now, you're probably thinking like, okay, well, what's the point? We think that a lot, don't we? This number right here, it should say, because this is a very fun fact, you guys, but this number in parentheses, and it's just a number, don't let scientific notation weird you out, it represents the weight of an ant. So essentially all they're trying to get me to do is they want me to multiply that weight by 3. So the answer I'm going to give represents how big is 3 ants. So that's what I'm trying to do here. I want you to note that this is not a distributive problem. Like, you don't take the 3 and distribute it to both parts here. You only distribute like that if it's addition or subtraction. All of this is multiplication here. So essentially, and I'm going to write a note off to the side, you just ignore the parentheses. They really don't matter because all this just means multiplying. So there's kind of a shorthand way of doing this without your calculator. Now, what I'm going to do, since I'm multiplying everything, I'm going to choose to multiply just these first 2 numbers here. Okay, obviously you can use your calculator, and bear with me, I forgot mine at school, so I'm going to use my phone. So I'm going to do 3 times 7.3, and that's 21.9. And then I'm just going to bring down that times 10 to the negative 5th. Notice the directions said, write each number in scientific notation. Okay, so I multiplied this through. A lot of people I think would be quick to say, all right, I'm done, but look at what I've written. This actually is not in scientific notation, and the reason is this first number, the first part, is not a number between 1 and 10. So I need to fix this to make this in scientific notation. So all I need to do is move the decimal. And I know that if I put it between the 2 and the 1, I'm going to have the number 2.19, which is in between 1 and 10. Okay, so that's not that bad. It's always times 10 to some power. Realize though, if you move the decimal, you have to change the exponent. Okay, otherwise you're not going to give me the correct answer, the correct number. So there's a little trick here, and I'm going to make a note off to the side, another one. Don't we love tricks? Yay. So the trick is, and I'm going to write out in words what it is, and then I'll show you what I mean on this example here. But the trick is, if you make the number smaller, make the exponent bigger. And then I'm going to say, and vice versa. So it's kind of like do the opposite. If you make the number smaller, you make the exponent bigger. Vice versa means it works the other way around. If you make the number bigger, you make the exponent smaller. It's a lot of words. Here's what I mean. Think about what I did to the first part. I made it was 21.9, and I made it 2.19. So I made the number smaller. Now think about how many times I moved the decimal. Well, I just moved it to the left once. So all I'm going to do is change my exponent by 1. And again, the trick applies here. I made the number smaller, so I need to make the exponent bigger. I only moved it once, so I'm only going to move this by 1. I need to make this bigger by 1. So that would mean adding 1. So negative 5 plus 1, that's actually negative 4. So that is my final answer. Again, I made the number smaller, so I make the exponent bigger. I only moved the decimal once, so that's why I added 1. Okay, I'm going to do one more of those. So again, this is not a distributing property or problem, so I'm just going to choose to multiply 5 times 8.8, which is 44. Bring down your times 10 to the 4th. Don't be quick to stop. This is not in scientific notation because it's 44. The decimal's right there after the 44. I need to put it in between the 4s, so that way I have the number 4.4, which is in between 1 and 10. Okay, if you make the number, so think about what you did to the number, it was 44, now it's 4.4. So I made the number smaller again, so I need to make the exponent bigger. And this is kind of redundant because it's the same thing, but I only moved the decimal once, so I'm only going to make this bigger by 1. Ah, that was kind of boring. Let's do one more, just for fun. I don't usually do this, but I'm going to add a C, just because I know you guys are having such a good time. So let's say they gave you like 46 times 10 to the 5th. Not 46, let's do 0.46 times 10 to the 5th. Okay, it's just a number, and if they said, hey, write this in scientific notation, it's really close to scientific notation, but this needs to be between 1 and 10. So I'd need to move the decimal between the 4 and the 6. So here's it working like the other way around, the little trick. It was 0.46, now it's 4.6, so I actually made the number bigger this time, so I need to make the exponent smaller. So I'm going to subtract 1, since I only moved the decimal once, and that'd be 10 to the 4th. Okay, that is officially your first lesson, and we will practice this stuff tomorrow. So I do not expect you to know everything right now, okay? This is just an intro. Tomorrow's class time, we will spend practicing all of this. You can ask all your questions, and make sure you leave feeling comfortable with scientific notation.